Today, we will see how can we shift log functions. Shift is just another way to say move. Now, today we will see how can we move log functions. Know that there's four types of movement. Either we can move a graph either to the upward position, either we can move a graph to the downward position, either to the right or to the left. These are the four type of movements that a graph can take. Either you can move up, down, right, or left. And we will see how can we move a function either on those four directions. So that's the main idea for today. Now, just like it says here, the main idea, you can shift or you can move a function by either adding or subtracting numbers to the original function. So know that when you have a function and you add a number in a specific place, you can move the function either in those four directions, either by subtracting or adding, and we will see that today. So for today, we will have a presentation. So here in blue, we have the original log function. Here, this is the log function. Basically, what this is saying is f of x equals log, and know that the base is always 10x. So in here in blue, we have just the function or the graph for the log function. Now, notice that here we have plus 0, so we're not doing anything to the original equation, which is just logs of x. I want you to pay attention as to what happens when we start to either add or subtract numbers in the specific places. You can either add or subtract numbers either inside the parentheses or outside the parentheses. So here, notice what's going to happen to the graph as we add a number outside the parentheses. So here, the blue is the original graph. And notice what happens to the graph when we start adding numbers outside the parentheses. Now it's going, look at the right, it's increasing. It goes 1.4, 1.7, 2. And now notice what happens to the graph as you increase numbers outside the parentheses. What you should notice is that when you add a number outside the parentheses, you're basically shifting your graph upwards. So if you add a number outside the parentheses, you're going to shift your graph in the upward position. Now, what happens when you have the log function and instead of adding, you subtract? Well, let's go back to our original state, which is 0. Whoops. So here, we're back to our original. Now, we're not going to add numbers outside the parentheses. Now, let's see what happens to the graph when we're starting to decrease or when we start to subtract numbers. Notice what happens to the original graph. Now, when you're subtracting, notice on the right side, outside the parentheses, those negative numbers are keep increasing, which is basically saying that you're subtracting numbers. Notice that the blue graph is going downwards now. So when you add numbers outside the parentheses, you are shifting the graph upwards. When you are subtracting numbers outside the parentheses, you are shifting the graph downwards. So here we have it in writing as a small summary. So let's go back to the lesson. Now, here, just like it was explained, you're going to be adding a number outside the parentheses, the graph moved up. So remember that if you add a number outside the parentheses, your graph is going to start to move up. Now, just like it was shown in the presentation, if you subtract a number outside the parentheses, now the graph is not going to move up, but it's going to move down. So just keep that in mind. If it's outside, either we move up or down. We move up if you add, we move down if you subtract. So now, what happens if you don't add or subtract numbers outside, but now inside the parentheses? Well, let's go back to our presentation here. Let's go back to zeros so we can start the original place here. Okay, so now we're back at zeros. But now let's see what happens when you either add or subtract numbers. Not outside, because we already saw that outside, if you add, it goes up. If you subtract, it goes down. Now, let's see what happens when you add numbers inside the parentheses. Notice what's going to happen to the blue graph. What do you notice? Notice that when you were adding numbers inside the parentheses, we were moving to the left. Let's do that again. This is original. Notice what happens when the numbers are increasing. Look at what's happened to the graph. It starts moving to the left. So now, if you're going to be adding numbers inside the parentheses, your graph is going to have a shift to the left position. So that says that if adding is to the left, then that means that if I'm going to subtract numbers, I'm going to be moving to the right. So notice that inside the parentheses, here's the original state, 0, 0. If you add numbers inside the parentheses, it moves to the left. And if you subtract numbers inside the parentheses, it moves to the right. So those are the 4 shifts that I was speaking of in the main idea of the lesson. So let's go back. So we know that if it's outside, you move up if you add. If it's outside, you move down if you subtract. So that means that here, if you add a number, and just like we saw in the presentation, if you add a number, but now inside, the graph is going to be moved to the left. And if you add a number, if you subtract a number inside now, then the graph is going to move to the right. So outside, up and down, inside, left or right. Now let's put this concept into practice now. So here, the original function, it's always going to be called the parent function. Here, well, it's too small. I don't know if you can see it there, but let me rewrite it. This is a function for just log of x. So this is our original function. And we know that our original function is always going to look like this. Log is always going to have this shape, passing an x1, 0. So let's draw our original function here. So 1, 0. Again, I'm just going to copy the shape here. So this is the original function. In blue, log, it's always going to look like this. So the original, it's in blue. Now, in red, let's graph our new graph, which is log of x plus 4. So notice that this plus 4 is going to have an effect on the graph. Notice that we're adding outside the parentheses, and just like it was explained here, if you're going to be adding outside, that means that the graph is going to move up. So our original function is the blue. And we know that because of this plus 4, we need to move the graph upwards by 4 units. So grab any point. I'm going to choose this point, and I'm going to move it 4 units upwards because that's what it says here. So we're going to go 1, 2, 3, 4. So here's our graph now. And just copy the same shape. And that is it. Here in red, this is the graph that we wanted. This is the graph for y equals log of x plus 4. Because if you add a number outside, it moves upward. So we got the original, and we move the graph 4 points up. So now, let's look at another example here. So here's our second graph. Again, the first thing that you should do is just try to copy the original. The original, it's always going to be what, at least in this case, we're just concentrating on log. And just log of x, it's always going to have this shape passing at 1, 0. So let me do in blue the original, which is also going to be called our parent function. So here in blue, we have our original. Okay, that was not straight. Okay, that's fair. So here we have again, our blue is the original. So now our task is just to graph y equals log of x plus 5. So we know that this plus 5 is going to affect the original graph. But now we got to think, well, which one of those four options was it? Well, we're adding inside the parentheses now. So let's go back. Now, when it comes to inside the parentheses, if you're going to be adding inside the parentheses, then that's going to have a shift to the left. So now we're going to get our original graph here, and we're going to move, I'm going to choose this point. I'm going to move this point 5 units to the left now. So that's 1, 2, 3, 4, 5. Here it is. Just copy the shape. And that is it. Here, the blue is the original graph, which we started to be log of x. And here in red is the graph y equals log x plus 5. So notice that because of that 5, we got the original and we shifted 5 units to the left. So now, here's your entrance ticket. Just describe in your own words the different type of shifts we have for the log function.